What if your AI could think like an engineer, breaking down problems and calling the right tools at the right time, automatically? You'll see how to build a self-directing agent that decides when to perform calculations, executes them with precision tools, and loops back for further reasoning until it reaches the final answer. The pattern uses LangGraph state management to create a clean, repeatable workflow where the AI stays in control of the process. From LangGraph, graph import messages state. From LangChain, messages import system message, human message, tool message. Hash nodes. Def LLM call state, messages state. LLM decides whether to call a tool or not. Return. Messages. LLM with tools, invoke. System message. Content equals, you are a helpful assistant tasked with performing arithmetic on a set of inputs. Plus state messages. Def tool node state, dict. It performs the tool call. Result equals. For tool call in state messages -1, tool calls. Tool equals tools by name tool call name. Observation equals tool. Invoke tool call args. Result, append tool message. Content equals observation. Tool call ID equals tool call ID. Return messages. Result. Hash conditional edge function to route to the tool node or end, based upon whether the LLM made a tool call. Def should continue state. Messages state literal tool node, end. Decide if we should continue the loop or stop, based upon whether the LLM made a tool call. Messages equals state messages. Last message equals messages -1. Hash if the LLM makes a tool call, then perform an action. If last message tool calls, return tool node. Hash otherwise, we stop, reply to the user. Return it. Hash build workflow. Agent builder equals state graph, messages state. Hash add nodes. Agent builder, add node. LLM call, LLM call. Agent builder, add node. Tool node, tool node. Hash add edges to connect nodes. Agent builder, add edge start, LLM call. Agent builder add conditional edges. LLM call. Should continue. Tool node, end. Agent builder, add edge, tool node. LLM call. Hash compile the agent. Agent equals agent builder compile. Hash show the agent. Display image agent, get graph x-ray equals true. Draw mermaid PNG. Hash invoke. Messages equals human message. Content equals add 3 and 4. Messages equals agent, invoke. Messages, messages. For M in messages, messages. M pretty print. This demonstrates the agent loop pattern, where an LLM dynamically decides between using tools or responding directly. The core concept is a feedback loop that alternates between reasoning, LLM calls, and action, tool execution, continuing until the LLM determines the task is complete. What makes this distinctive is its ability to handle unpredictable workflows by delegating control flow decisions to the LLM itself. The pattern works by separating concerns into discrete phases. The LLM evaluates the current state and either returns a final answer or invokes tools, while a routing function determines the next step based solely on the LLM's output structure. This creates a declarative control flow where the graph defines possible paths, but the LLM selects the actual path at runtime. The circular connection between tool execution and LLM reasoning forms a persistent loop that only terminates when the LLM stops requesting tools. This approach solves the problem of rigid workflows by introducing dynamic branching without hard-coded conditionals. It's particularly valuable for tasks requiring multi-step reasoning or external data, like calculations, API calls, or database lookups.
The trade-off is increased complexity in debugging, since paths aren't predetermined, and potential for infinite loops if the LLM's tool use logic isn't properly constrained. You'd use this when the sequence of operations can't be known in advance, but you still need structured interaction between reasoning and action. Let's break it down.
From LangGraph, graph import messages state. From LangChain, messages import system message, human message, tool message.
Imports the core state management class, messages state for tracking conversation history, and message types, system message, human message, and tool message for structured AI interactions. These form the foundation for building stateful, tool-using agents in LangGraph.
Def LLM call state, messages state. LLM decides whether to call a tool or not. Return, messages.
The LLM call node takes the current message state, prepends a system prompt, and invokes the LLM with tool calling capabilities. It returns the LLM's response, either a direct answer or tool invocation requests, wrapped in a messages dict, which becomes the new state for downstream processing.
Def tool node state, dict. It performs the tool call. Result equals. For tool call in state messages -1, tool calls. Tool equals tools by name tool call name. Observation equals tool. Invoke tool call args. Result, append tool message. Content equals observation. Tool call ID equals tool call ID.
This node processes all tool calls from the LLM's last message in parallel, invoking each tool with its arguments and returning a list of tool message objects containing the results. Each response preserves the original tool called for proper LLM context tracking in subsequent turns. The output format matches LangGraph's expected structure for tool execution results.
Return messages, result.
Returns the process tool responses in the required state format. This maintains the message chain structure expected by LangGraph, where each node must return a dictionary with a messages key containing the updated message list.
Def should continue state, messages state literal tool node, end. Decide if we should continue the loop or stop, based upon whether the LLM made a tool call. Messages equals state messages. Last message equals messages -1.
This conditional edge function extracts the latest message from the state to determine workflow routing. It checks whether the LLM's response contains tool calls, which dictates whether to continue processing or return a final answer. The pattern enables dynamic control flow in agent execution.
Hash build workflow. Agent builder equals state graph, messages state.
Initializes the workflow using LangGraph's state graph. This creates the foundation for our agent state machine, where each node represents a step in the processing pipeline, and messages state defines the data structure passed between nodes. The builder pattern here enables clean, declarative construction of complex workflows.
Agent builder, add node. LLM call, LLM call. Agent builder, add node. Tool node, tool node.
Registers the two core processing nodes in the workflow graph. LLM call handles AI decision-making and tool invocation requests, while tool node executes the actual tool operations. This establishes the fundamental processing pipeline before defining how they connect.
Agent equals agent builder compile.
This compiles the state graph into an executable agent. The compilation step validates all nodes and edges, ensuring the workflow is properly connected before execution. Without this, the graph remains just a blueprint.
Hash show the agent. Display image agent, get graph X-ray equals true. Draw mermaid PNG.
Visualizes the agent's workflow as a mermaid diagram. The X-ray equals true parameter reveals internal state transitions, helping debug complex routing logic between nodes.
Messages equals human message. Content equals add 3 and 4.
Initializes the conversation with a user message. This human message object creates the starting prompt add 3 and 4 that kicks off the agent's workflow, demonstrating how external input enters the system.
Messages equals agent invoke. Messages.
This triggers the agent's execution with the initial message list. The invoke method runs the entire workflow graph we defined, processing the messages through the LLM and tool nodes as needed.
For M in messages. M pretty print.
Iterates through the final messages and prints each in a human-readable format. The pretty print method handles complex message structures like tool calls and responses, making debugging and output inspection straightforward. LangGraph agent construction. This implementation demonstrates the core pattern of building stateful, tool-using agents where the LLM dynamically routes between reasoning and tool execution based on message content. The should continue function must examine the last message in the state for tool calls, as earlier messages won't reflect the LLM's current decision point. State management through messages state creates a clean loop between LLM reasoning and tool execution, with each node transforming the message history in a predictable way.
The edge that connects nothing becomes the path of all return.